So I was talking to everybody a little bit before we got started. So I understand we have a very broad audience here tonight, from everything from residential cleanup to megawatt on the facilities maintenance side, service side. So this is going to be a presentation that more or less appeals to all of you, and you'll be able to relate to at least some part of it, probably given the jobs that you've done, the work that you do. So I would encourage just questions as we go through it. Kind of makes it a little bit more relevant, keeps a little bit more interactive. In terms of what Generac does, we've got that recognition largely in the residential space, but we also are a leader in the natural gas space and the diesel space. Single engines up to 2 meg, and those can be paralleled. If you have a small village that needs to be powered up on generator, we'll gang 32 of them together for you if you like. In terms of natural gas, 750 kW, single engine, we can gang those up as well if you like. We were talking about gas piping before. These have a tad of an appetite. They like around 7,800 cubic feet an hour, so that's some big pipe. We could talk about gas piping too in a different class. That's also another great technical topic that we could cover. So Generac has been growing. We're the leading natural gas engine manufacturer, generator manufacturer in North America. So that's something that we're very proud of. In terms of some of the distribution channels where you've probably seen us, recognize some of the names there in terms of the distribution channels. We go to market a couple different ways depending on the product. You know, everything from the small stuff that you can get out at Home Depot all the way up to the industrial product that, you know, we'll sell directly from the factory and through our distributors. And then the commercial product that probably fits into a fair amount of the jobs that some of you see and work on a regular basis. So in terms of emergency power system, we're going to talk about the design, the installation, the aspects that are going to make for that system to be reliable over the long term. In other words, what are we going to do from the initial system design so that we can avoid some mistakes, maybe spot some design changes that you could see, you know, early in the project, offer some value to your customer, say, hey, you know what, we haven't really started on this, might I suggest we do it this way? And we'll talk about some of the things that you might see, some of the changes or some of the conditions that you might want to correct. We'll look at sizing, the different generator sets that you might use, outdoor, indoor locations, some of the implications that come along with either of those choices. We'll talk a little bit about fuel, diesel and natural gas, the challenges that come along with diesel and the maintenance requirements that kind of come with it, the increasing role that gas is playing, touch a little bit on the code requirements for gas, but not too much because that's still a moving target, and then a little bit about exhaust emissions. Now, oftentimes, you know, you're kind of faced with stuff and it's, hey, I'm in there, I'm doing what I got to do. Just remember, just because you can doesn't mean you should, right? This is a concoction out west that came from my telecom days. I spent 23 years in telecom. This is a place where they just didn't want diesel. Okay, it worked. It wasn't pretty, but I told the guys that sent me that picture, I said, I never want to see that picture again. I don't care if you ever use it, just don't tell me. And that's where we left that one on there. In terms of system types, if you crack open the National Electrical Code, you're going to find that they're broken down into 3 broad categories. So emergency systems, Article 700. This is your 10-second start, essential for human life. So when you're talking about an industrial product, for example, from Generac or any of the other large manufacturers, this is usually the target that we're hitting, that we've got to hit, is that 10-second start. Second category is legally required. So this would be some usually like smoke ejection systems, some elevators, depending on what the elevators are used for. You get a little bit longer to start those. You get 60 seconds to bring those loads online. And then the third broad category is Article 702, optional standby. This includes virtually all business applications, a lot of telecom stuff, cable TV, stuff where people aren't going to die, but usually there's a lot of money at risk, so there's a financial incentive to keep the service or the system running. As you're getting into that initial design, I mean, I got to figure, show of hands, who's gotten involved directly in sizing on their own? Okay, you guys have done sizing. Roughly what size machine?
Well, residential-wise, it came out to be like 16 kW residential-wise, but in facilities maintenance, it ended up being much larger than that. It came out to be like 75
Okay.
kW.
Okay, and did you do that just kind of on a spreadsheet, or did you use one of the vendor tools?
Had an engineer involved in it also.
Okay. You can use any of the vendor tools. So for example, Generac sizing program, Power Design Pro, all the generator manufacturers have their own kind of flavor of it. I would encourage you to use that. Even if it's what you think a very easy load, a very easy project that you're going to just set up, don't grab that last electric bill, look at the peak demand charge and say, hey, my work here is done. You're a long way there. That's a great place to start, to go get that billing history and look at that peak demand charge for the 12 months. But what are you going to miss on that? You might miss some nonlinear loads, some horrible kind of harmonic content on there. The sizing programs will help you identify that and pick that out. Anything that creates a leading power factor, if you've got a little data center or UPSs that are stuck throughout your building, if those have caps in them, they can sneak up on you and cause a leading power factor. Generators don't like that. They get unstable and they become very unhappy quickly. A place where you can add value for your clients. If you've got some larger motors that you've got to start. Motors want some serious current when you start them across the line. And that's going to drive your alternator size. You may have to upsize an alternator on there. Think about changing out that starter. Maybe put a VFD in there. Then you can talk to Chad too, get some credits too. Okay? That's going to significantly reduce that starting current requirement for that motor. You might be able to kind of save the expense of upsizing an alternator. And your end user saves some money a little bit too. So kind of a win-win. It comes down to, where am I going to throw the money? Am I going to throw the money at the alternator on the generator set? Or am I going to spend a little bit of money on a VFD? Customer is going to spend it. They've got to start that motor one way or another. Maybe add a little bit of value, every day when that motor starts, anytime. We'll want to specify the load, the transfer startup scheme. Do they want the lights to go out, right? Are we going to transfer to a neutral position, let motors spin down, and then roll over to our generator? Depending on your loads, that might be the way to go. Or do I have a very generic kind of office environment? I don't really have anything special in there. Kind of the idea is to minimize that outage. Maybe I use an in-phase transfer switch, which can roll from the utility over to the generator very, very quickly, and then similarly from the gen set back to the utility with almost no break. Go ahead.
Question about the VFDs. And if you do take advantage of the VFD and you downsize the alternator and the customer has a reason to bypass the VFD, do they know that they're not going to be able to run that equipment during that time?
Well, yes, and it depends. So actually, that's a great question because it plays directly into especially fire pumps. So anybody that's started a fire pump, I can't have more than a 15% voltage dip on a fire pump when I do a normal starting technique, like with a VFD. If I have to bypass that VFD and do an emergency start, the genset still has to do it, but it can be ugly. It could be a 25 or a 30% voltage dip, but the generator still has to be able to do it. Go right back to that sizing software. You can do either scenario very, very quickly in the sizing scenario and say, okay, I downsized my alternator, but did I do it too much? And you will find some cases where, wow, I can't get it all the way down. I can save maybe one or two upsizes. Good question though, thanks John. All right, as we talk about, we'll start with outdoor installations. These are kind of the most typical thing that we would see. That's kind of what we're used to, is the generator in the box sitting outside, right? We've got a bunch of pictures of them around here as well. Noise, that's the thing that everybody thinks about. You talk to a client, talk to a customer, what are they worried about? Noise. How noisy is this thing going to be? How am I going to make it so I can't hear it? The architects, if anybody deals with an architect, they don't want to see it either. They don't want to see it, they don't want to hear it. We'll see some fun pictures of that later. There's generally different flavors of sound attenuated enclosures, and you pay accordingly for it. So you want a generator to be as quiet as it needs to be. Just be aware that if you start going very, very quiet and get into custom enclosures, now your price starts going up a lot. So take advantage of distance. Let's say if you need to meet a certain sound target at a property line, try to maximize that distance, right? If I can get the gen set a little bit further from the property line, maybe I get myself back into just a standard enclosure, a standard factory enclosure. You avoid the expense of a custom enclosure. You can do screen walls, sound barriers, sometimes, you know, shrubs kind of buy you that little extra margin that you need. Weather protective enclosures, they are not submersible, watertight. You know, you are going to pull some moisture into them. When this machine starts, I'm moving 10, 20, 30,000 CFM through the enclosure. If it's raining out, some of the water's coming with it, okay? Operationally, you're on the facility side. Somebody puts a generator somewhere, and I have, you know, 6, 7 feet of snow like we had up there in Buffalo. How am I getting the snow away from it? How am I getting the snow around it? Guarantee the engineer that's doing the design is not thinking that far ahead. It's the operations guy that's going to go, oh, geez, I got to refuel this thing. There's 3 feet of snow around it, and there's like no way to get the truck there. If you're going to put the gen set on the roof, I don't have any pictures of them around here, but consider extending the lightning protection system to include the generator enclosure. If the building's got or is going to have a lightning protection system on it, it's super easy to just extend those conductors over the generator enclosure. They'll just kind of epoxy the air terminals onto the 4 corners of the gen set. The cables will run down the side of the enclosure and you're good to go. In terms of ventilation, think about the enclosure. Most of them now will vent vertically upwards, so you're taking your radiator exhaust and you're taking your exhaust gas and you're pushing it straight up. So you're really starting to kind of disperse and diffuse that exhaust gas, getting it away from the ground, so that helps with any kind of objectionable odors and whatnot. But you've got to have clear space above you if that's the style of enclosure that you use. There are still some manufacturers out there where you'll just have radiator, maybe some louvers, and it's all going to blow horizontally. But that's becoming less and less common because they're just so loud, you know, and everybody wants their gen set to be quiet, at least in some respect. In terms of exhaust, you don't always get to take advantage of this. Like I said at the beginning, sometimes you're kind of just stuck with what you're stuck with and you got to make the best of it. But use those prevailing winds. You know, if I'm going to put this machine somewhere and I'm going to put whatever 1,500, 2,000 CFM of exhaust gas into the air, what's this over here? I hope that's an exhaust and not an intake, or you're going to have some very unhappy folks in that building, okay? Just don't terminate exhausts near an intake, or near an air intake. And oddly enough, if you can avoid mechanical rain caps, avoid them, unless you can get to them. Murphy's Law totally applies here. If you can get to and touch a mechanical rain cap, it will never ever give you a problem. In 100 years, it will never give you a problem. The moment you put it out of reach, it'll seize up or it'll get iced over or something like that. Kind of relating to your starting question before, your motor starting question before, I've got to get the engine started first. So in terms of a diesel engine, I've got to keep that engine warm. We start getting into some of the code requirements, NFPA 110. You know, I've got to have that engine up and ready to accept load in less than 10 seconds. The only way I'm doing that with a diesel is that engine's got to be kept warm. Typically that includes, at a minimum, a block heater. Sometimes lube oil heaters, although we discourage them because they tend to locally heat the oil, and you can actually start locally breaking down the oil because that probe gets so hot locally. Typically a block heater is, in this part of the country, it's all you need. Right. Battery heater is kind of the same thing. I would encourage you to use just a larger battery before I encourage you to put a battery heater on there. They just have a tendency to cook off the electrolyte over time, and I'd say they create as many maintenance issues as they solve. Right. In colder climates, not so much here in kind of the greater Philadelphia area, but as you get up into upstate New York, you get up into New England, you'll start seeing options like motorized dampers. okay, to help keep the heat inside the enclosure. You'll also start seeing, in addition to a block heater on the engine, you'll see a space heater inside the enclosure. 2,000, maybe 5 kW for some of the larger enclosures. You know, on a bigger gen set, it is not uncommon that you might have 7,000 watts worth of heating load in there. You know, that's going to have an operational expense impact for the client as well. Which is why, you know, minimizing some heat loss, minimizing the heat loss from the enclosure is good. Let's say you have no requirement for sound attenuation. Nobody cares how noisy the gen set is. There's places where it doesn't matter. You might even think about just using a level 1 sound attenuated enclosure, because you get the insulation in there that has some thermal benefits too, and it can cut down on that electric heat cost over the life of that gen set. Just kind of one example here of this is probably a 750 or a 1 meg machine. You can see they put the stairs around it to help maintain access to inside the machine. This is all stuff that can be ordered. You won't see it on a cut sheet for a gen set. Typically that's when you would get a distributor involved, you know, for the stairs, custom tanks, standard tanks. Those requirements vary, and you'll see that most manufacturers have at least kind of a standard tank offering. If that doesn't meet your requirements, go aftermarket. They'll do whatever you want. Keep in mind too that one of the standards for base tanks, for fuel tanks, anybody ever heard of UL 142? Diesel base tanks or above ground storage tanks? All right, that's the standard for above ground storage tanks. Just be aware that in some locations, they have their own requirements over and above that. So if you go in there with kind of a bone stock UL 142 tank and think, hey, I'm all good, I don't have to worry about anything, you might miss monitoring. You might miss, for example, this is like a spill fill bucket on there. That's a local requirement. Just typically the consulting engineer is going to be responsible for knowing this stuff. They don't always catch it. So be aware, if you know that your locality has some tank requirements, just try to read up on them. You do rooftops too. So rooftops have some different requirements. Obviously, you've got to make sure the generator stays on the roof and doesn't end up on the floor below. So there's going to be some structural upgrades that have to take place. Depending on who's below, if it's residences, you may have to do some vibration isolation. Again, this is something that the engineer is going to take care of. They're going to put vibration isolators in the design if they think so. It'll be a little bit warmer up there because of the roofing material. If it's a diesel, there's going to be some type of fuel storage, a fuel transfer pump system up there. I'm going to have my main tank down below, and I'm going to have some limited amount of fuel up top. Typically, it's at least 2 hours. If you're running in, let's say, New York City, some other jurisdictions, or if there's a fire pump on it, you're looking typically for a minimum of 6 hours. That's another requirement that has some variability to it. Service access. And I don't actually mean service access around the machine so much as what's the agreement that the servicing contractor, the servicing distributor has with that building management, right? If you're not there at 2 a.m. on a Sunday and the machine goes belly up, do you have to go there? Is there some type of arrangement in place where the generator service vendor can get to the machines, you know, by himself, right? You know, and so this is kind of a consideration that has to come into the planning, really more with the owner. It's kind of after it's left our house here, right? Our responsibility has ended, but you know, as you're talking about design with your clients, hey, what are we going to do to get the service guy up here if nobody's in the building? Just in case anybody questions it, generators burn some fuel. They generate a fair amount of waste heat. They're going to want to get rid of that waste heat. If they don't get rid of that waste heat, they get very, very unhappy. And I mentioned earlier that architects don't like how generators look, so they have tendencies to try to hide them. It's not going to run very long, I don't think. I've seen generators in pits. I've seen generators that have had such dense vegetation planted around them that there's no way they're going to ventilate properly. Depending on what you have growing around you, your radiator could look like that air conditioner there. If you got a bunch of that cottonwood or whatever it is on that radiator core, the genset's not going to last long before it goes down on overtemp. And the worst part is, you'll get them commissioned, you'll get the thing built, maybe it's okay, and then 2, 3, 5 years down the road, somebody has the bright idea that says, I'm going to hide this. I'm going to fix this. Cool, you fix it. We'll be there to clean up the mess. All right, so yeah, the vegetative debris, that has some huge variation across the country, and it's also very seasonal. I mentioned that I work in the telecom industry. We had a site down in Texas that was like near cottonwood forest. Just imagine a dandelion the size of a tree, and then an entire forest of that. They actually would disable the generator exercise cycle during that part of the year, because if that genset ran, it was an immediate call to the service technician, because we're going to have to hose that radiator out. I mean, that's kind of an extreme case, but you know, you can run into situations like that. So we can put them inside. We can go inside as well. If I'm going to put the generator inside, this kind of opens up a whole different set of concerns. You can do it. I wouldn't be discouraged by it. I wouldn't be scared away from it, but just understand that you have some other concerns. Mostly, the consulting engineer is going to deal with all of these, and you're going to be kind of on the execution side. But you're also the one that hopefully, well, maybe not hopefully, but if you see a mistake, that's kind of the last chance to catch it and apply some corrective action. You've got to have that airflow. You've got to get the airflow moving through there, get that air out of the room, okay? When that machine starts, that room is going to get really chilly in the wintertime. I hope it's not wet pipe sprinkler systems overhead. We're going to have a bunch of frozen pipes. The room's got to be fire rated. There's got to be fire suppression in there as well. You've still got to maintain all the NEC required clearances around that machine. Okay, so that has to be taken into account as well. At some point in the distant future, 20 to 25 years down the road, somebody's going to want to replace that genset. Did you put layers of floor and roof over that such that the only way that machine is coming out is in pieces? I just did that up in Massachusetts. I've got a project that's going on in Washington, D.C. right now, where they're fixing to plant a 500 kW genset two floors below grade. I have no idea how they'll ever get it out when it needs to be replaced. But yeah, you're going to cut it up. That's what they're going to have to do. But it adds just huge expense, and God forbid something catastrophic happens to it during its normal life cycle. If it needs an alternator replaced, if God forbid an engine goes, this stuff doesn't happen all that often. But if it does, you took what was already a bad day and turned it into a really, really bad day just because of where the machine was located. We look a little bit again at ventilation. If I'm going inside, ideally this is kind of the airflow pattern that I want. I've got to get air moving across that alternator because there's a fair amount of waste heat coming off of that as well. I've got to pull across the generator itself or the engine itself, and then finally it's going to hit the radiator and out it goes. If I were to do something like this, I'm going to end up overheating back here. I'm not going to be able to reject the heat from the alternator effectively. This whole backside of the room is going to start to get a little bit warm, and you're going to start to have issues. All right. In terms of exhaust, I've got to have a condensate. I've got to have a condensate trap. If I've got an extended exhaust stack, you've got to put a condensate trap on there. How do most people exercise their generators? They light them off for a 20-minute unloaded exercise. You are never, ever, ever going to heat up that exhaust stack. All the vapor that comes out of that engine is going to condense right in here and run right back down that exhaust stack. And if there's no condensate trap in there, all that water is going to end up right in the engine. And the engine is not going to like that. You get to do that maybe 1 or 2 times, and then you get to buy a new engine. Don't terminate the exhaust near the building air intakes, of course. We had operable windows on there. And typically, an exhaust stack system like this is going to be part of a system, whether it's Selkirk or whoever is providing it. they're going to be the ones that provide building the wall thimbles. They're going to provide the brackets, the way to affix it to the wall or the ceiling. Get it as a system. They're designed to work together. Things like thermal expansion, how all that is managed is all dealt with when you deal with a single vendor for stuff like that. And they've got to be sized adequately. The only way that engine is going to make horsepower is if I can get that exhaust gas out of there effectively. The sizing tools that I mentioned earlier will help with that. If you've got a 50-foot vertical exhaust stack with, let's say, 290s in it, it's going to tell you what diameter that pipe needs to be so that you don't exceed the maximum back pressure on the engine. So now, these are kind of common no matter where the generator is located, inside or outside. We already mentioned that the diesel's got to be kept warm, block heaters, jacket heaters, etc. We're going to minimize the heat loss from the genset itself. I could do motorized or gravity dampers on the intake or the exhaust. In extremely cold locations, you may want to do that. But if that is a requirement, make sure they don't freeze up. So you're going to have to put some type of shield over them so they don't get iced. And in some extreme environments, they'll even heat those things. They'll even put like strip heaters on those louvers so that they don't ice up. All right. Getting back to kind of diesel fuel systems before we shift gears over to gas. Traditionally, you'll see a base tank on a diesel gen, kind of like the picture over there to the right. That's a large diesel base tank on those generators over there. You could use a base tank just all by itself, maybe a bigger one, or it could be a day tank. You could get a very short base tank that's coupled to a larger main tank and has a pump package that goes along with it. If you're going to use a remote tank with a day tank, it's got to have at least 2 hours of fuel in there. So if you've got a 500 kW gen set and it's going to burn, 30 gallons an hour, you want that tank absolutely no smaller than 60 gallons because the injector pump in that engine is cooling itself with that diesel flow. So it's circulating that diesel fuel, and a lot of it is being bypassed through the pump, returned back to the tank. If that tank's too small, that fuel's going to heat up. It's going to start to foam. I'm going to start to ingest some air into my fuel system, and then that's it. Engine's going to stop. Okay. Make sure the transfer pump is on emergency power. Had that happen to me too. Yep. Everything ran like a champ for 2 hours and then fell on its face. You guys, when you're doing your accessory supply power outside, and this is going to vary based on the gensets that you see, some engineers are going to say, I want a separate accessory power run out there for the battery charger, the block heater, the enclosure heater, whatever. But a lot of the manufacturers, including us, will actually put a little sub panel out there in the genset. So it's one feeder for you guys to pull. It has to be sized appropriately, saves you a little bit of time in terms of labor, and then you don't have to figure out, where do all these things go, the terminal strips, what's got to be 120, what's got to be 240. Just pull a 240 or a 208 volt, 2-pole circuit out there, size it appropriately for the size of the genset and the heaters in there. That'll all be provided to you. It just saves you a lot of aggravation and a lot of time out there on site. That's what happens to diesel fuel if you don't take care of it. It turns into something that looks like diesel fuel on top and sludge on the bottom. And where's the pickup tube for my engine? Yeah, it's down here in the yummy stuff. So when that engine starts, if that's what your fuel looks like, you get about a minute or two out of it, and then the engine just kind of coughs and dies. For the larger installations, for the larger systems, or where the AHJ requires on-site fuel, it's still sometimes your only option. As long as the owner or the end user understands kind of the obligation and the maintenance requirements that come along with diesel fuel, they're going to be fine. Data centers, hospitals, large institutions, they know what they signed up for, most of them, you know, when they're dealing with diesel fuel, and they have, on average, they take better care of it. You got a small school system, or let's say just kind of a one-off customer who probably doesn't even know what diesel fuel smells like. They're probably not really going to resonate with them how important this is or why it's important. Maybe they would be a little bit better served with either a natural gas engine, or if it's small enough, even propane might be better. It completely eliminates that whole fuel maintenance piece. And really, that fuel maintenance, that's out of all of our hands, right? In terms of long-term reliability for this system, that totally hangs in the balance with what the owner does. And you know, we're the ones that know. So you kind of have to make that call. You got to make that judgment call. Does my end user, does my system owner, do they understand what they're signing up for here? And do I think that they're going to maintain this properly over time?
What do you have to do?
It's called fuel polishing. It's essentially like dialysis. So they'll go in, they'll pump out the engine, they'll circulate the fuel, they pull it through a series of filters. They just run this for a couple of hours. It takes out the water, takes out the microbes, all the algae growth, and then actually puts in some stabilizers and some fuel conditioners, and it'll go back into the tank. Typically, diesel will last about a year before you have to think about polishing it. And then depending on the environment, 2 years, maybe 3 years on the outside, even if you're polishing it. If you haven't used it in 3 years, pump it out, replace it, because it gets to a point that even polishing doesn't do it anymore. All right. And you say, well, man, that's pretty horrible. That's kind of sucks, and it does, because now we're using ultra low sulfur diesel. If we were to wind back the clock 15 years or so, when we still had a fair amount of sulfur in that fuel, it was a lot more stable. It lasted a lot longer. It was much more tolerant of storage. Not so anymore. Thank you, EPA.
And biodiesel makes it worse, guys.
Yes.
Oh.
Do not put biodiesel in a genset ever. Okay. Can you say that again, Shirley? What do we never do?
No biodiesel.
No biodiesel.
What is biodiesel again? Make sure we know what that means.
And
So-
now your fuel vendors only have to tell you when they go over 5%. So they can go 5% or less without telling you that you have biodiesel or not biodiesel.
Right, so biodiesel is a vegetable-derived diesel fuel. They basically take used grease from a food service industry, and they kind of distill it and do some chemical stuff to it. And it pretty well resembles diesel fuel. And it runs and has about the same BTU content as diesel fuel. Unfortunately, it does not have, you thought the shelf life of diesel fuel was bad?
6 months or less.
The shelf life of biodiesel is even worse. Good. Go ahead.
Just to let you guys know that we do offer the service of fuel polishing. We have the machinery, so if you have any customers you're looking to do that with, let us know, and we can do some fuel samples for you, and also get you some pricing of what it would cost to do this procedure on the units. Thank you.
Surgical procedure.
There you go.
All right. So now that we've scared everybody away from diesel fuel, now let's start talking about natural gas. So you got to have pressure and volume. As I said to the guys over here before we started, we are not hooking up a barbecue grill here, folks. These things have an appetite. 500 kW genset, for example, is going to look for about 5,800 cubic feet an hour. If you don't pipe that properly, the thing is going to fall on its face when they go load bank it. Okay? You may have seasonal variation in that gas pressure out there on the street. If you go and commission a genset in the middle of summertime, hey, life is good, I got 11 inches on the street. You go run that same genset in January when all the furnaces are running and I got 6.5 inches, now that's not enough for the genset. They have packaged gas boosters. If somebody gets into a jam with that, we can fix that. And you're only going to see those issues under heavy load. You're going to unload, do an unloaded exercise, or run a genset with light load. It's going to be fine for the most part, even if it's not getting awesome gas flow. You make it try to work. If it doesn't have good gas pressure and adequate flow, it will let you know very quickly that it's not getting enough gas. Typically, there's no on-site fuel storage, but there is a flavor where we do bi-fuel gensets that use diesel and natural gas. You may have heard the term dual fuel. Just want to differentiate these two here. Bi-fuel is a diesel engine. It is a compression ignition engine that we supplement natural gas into that extends the runtime on that given fuel load of diesel. Okay? Dual fuel is one that will run on natural gas or propane. This is a compression ignition engine. This is a spark ignited engine. Okay? Dual fuels kind of run out of gas at about the 150 kW mark. And it's just because I can't turbocharge an engine as much when it's running on propane as it is on natural gas. So it becomes just more and more uneconomical to run a larger engine on propane. There are vendors out there that make them. But for example, 22-liter engine on propane will get you barely 300 kW. I mean, that's an enormous engine for not a whole lot, not a whole lot, but relatively speaking, not a whole lot of power. If you're doing natural gas, just be aware that they respond a little bit slower than diesel. So your frequency dip is going to be a little bit deeper. The recovery time is going to be a little bit longer. You can design around all this. You can size the engine appropriately such that you still meet your performance requirements. Just be aware that it is a little bit different than a diesel engine. Okay. In terms of exhausts, the EPA gets into the game too. We've got to meet the EPA exhaust emissions requirements when these things are going into service in the United States. Most manufacturers are going to have their products, or at least most of their products, certified, EPA certified from the factory, but you have got to check. If that product rolls out and it's not EPA certified from the factory, when year 3 rolls around, it's got to be field emissions recertified. We have a couple of 500 kWs out on the New Jersey Turnpike that were built by a competitor. I won't tell you what the manufacturer is, but they're green. And they're coming up on 3 years old. And they're getting bills for about 15 grand a piece to do field emissions recertifications on these. If that engine comes out of the factory emission certified, the client never has to do that. The customer never has to do emissions recertification. And that's a huge savings for them down the road. Right?
Every 3 years too, right?
Every 3 years. Every 3 years. So you do the, go ahead, John.
We had some large 2 megawatt units that were installed, and the facility was limited to the number of hours they were allowed to operate them per year, because they were only allowed to contribute so much to the atmosphere.
Yes.
And when they did the commissioning on them, they found out that they were actually putting out more, so they were pulling their hours back.
So that's when you get into like a Title V air permit, where you start tallying up the hours and how much each contributor puts in. For most of you guys here, you're never going to run into that. You're going to fall well below like a Title V air permit.
They had 8 2 megawatt units.
Yeah, and I'm sure a few other things on their campus that was putting stuff into the air. So, yeah, in those cases, you gotta get your environmental lawyer on staff and start working. All right. Emissions considerations. There are places that have some tighter requirements, even on emergency engines. I would say don't worry so much about this other than whatever product you buy, just look on that cut sheet, make sure that it says EPA emission certified for emergency stationary or emergency standby use. Anything else in terms of like Title V, if you're into a project that is that large, there's an engineer and it's his or her job to worry about that. Let them do that because it is horribly confusing space to be, and let them suffer through all of that. If you want to use a diesel engine in a non-emergency application, say for demand response, it's got to be Tier 4 compliant with emissions. So that means you're putting a urea injection system on there, exhaust catalyst, SCR. You're almost doubling the cost. Plus you're adding a whole new layer of maintenance and reliability challenges to it. Can it be done? Yes, it can be done. However, when folks start looking at the economics of using a diesel engine in a demand response application, it's the economics that usually kills it. It's because it's just too darn expensive to do this in most cases. So, any questions so far? All right. Nice little gas gen set. Well, maybe not. So, I said earlier, just because you can doesn't mean you should, right? So what happens when the dumpster catches on fire? So that's going to be a bad day. Kevin, you're on the facility side. So it's your job to coordinate the dumpster swap, the high lift, with the oil change. That just got to be a real fun job on oil change day. And I know somebody's going to check that on a regular basis.
Hey, Mike, it's kind of hard to see the lights. Can you explain what, there's a generator up in the air, right?
Yes, there's a generator that is, I don't know, 12-ish feet off the air, or 12 feet off the ground.
That's better. There you go.
Yeah, right, we're going to maintain that one. Hey, they're keeping it warm. We'll give them points for keeping it warm, okay? So know the scope of work in any maintenance contract. So now you start getting into, we're starting to get ready to leave the scene, right? We've done everything we can in terms of design. We've installed it as best we can. You know, we've mitigated as many risks as we can in terms of the original layout, the original design. But once we get into maintenance, at best, you can kind of have some parting advice for your customer, or if you happen to provide service, then hey, then you provide service and you can kind of continue that relationship and drive that reliability. NFPA 110, if this is an emergency or a life safety application, there's quite a bit of responsibility that's put on the end user. They've got to do record keeping, they've got to do testing, they've got to do regular maintenance. Chapter 8, Section 3 and 4, if anybody wants to go read them, you can grab them and at least look at them for free on NFPA's website. Beware of your cut rate maintenance programs. The guys that come in and offer to change the oil and filter for $250. I caught guys when I was, again, back in my old career, their idea of an oil change was a little WD-40 on a paper towel, which takes Sharpie marker off an oil filter really effectively. You wipe it off. And you write today's date on it, and you put the engine hours on there right now, and there you go. Maintenance is done. PM's ready for another year. Okay? If somebody's giving you a price that seems too good to be true, you know, be very suspect of it, because that's the type of shenanigans that goes on there. Use your authorized factory distributors for service, or if you're a distributor yourself or a servicing agency yourself, you know, hey, we do it, we might cost more, but you're actually getting work done, okay? You got the trained technicians, you can leverage the commonality between the different components, and you tend to get a little bit better response time with a bigger organization. You can get these machines that are typically gonna last 20, 25 years, right? You gotta keep those records, because we're gonna have turnover, right? I'm gonna have turnover in those people. So what I knew about the machine on year 3, those people are going to be long gone by year 7, year 8, year 10. If I've got large fleets and you keep that historic O&M data, that is historic operations and maintenance data, now your finance people can start doing some planning for capital replacement. You know, some of this stuff is pretty far out, but has some implications way out in the life cycle. And if you got a corporation or a large entity that is kind of on the green kick, there you go. You can slide in there and maybe push them over to a natural gas engine and get them off the diesel bandwagon. In terms of operational checks, so whether this is you doing it or if you have facilities folks that can do it, You may want to do some additional training. Again, we're going to have some turnover in those folks. And if you get a trained person on site, they can tend to do quite a bit in terms of just basic triage, right? If I can get somebody on site to do some basic triage and I still have to call a service tech, I've at least given them a better idea of what the problem might be. And between PMs, for anybody that happens to be there, look, listen, and check. If the thing is exercising, just listen, right? Is it making funny sounds? Open the door and look inside. Find out if Mother Nature decided to take up residence inside your generator set. Because she will. She'll get in there if she can. Okay? The abnormal conditions, right? Just again, look around. Do I see signs of tampering? Is somebody getting in there? Are there leaks? Do I have blockage on any of the air intakes, any of the exhausts? If people get into the routine of doing this, you're gonna eliminate a lot of the failure modes just because somebody is being proactive, checking on them. So many failures are caused by human error, right? So what can you guys do in terms of your installation and your maintenance practices? But mostly this kind of shifts back to installation. Put the remote annunciator where somebody can see it. Okay. A lot of times we'll see them mounted near the fire panels. That's kind of a good space for them because that tends to be in an area of the building that gets some traffic. Put it in the maintenance manager's office if there's somebody there. The point is, put it somewhere that somebody's going to see it and look at it on a regular basis because, hey, generator not an auto. That's an easy one to fix. Output circuit breaker open. It happens. Somebody will go in there to do some work and they think they're going to be super safe and they'll flick that circuit breaker open. They won't close it when they're done. Happens. What's that big shiny red candy-like button? I think I'll push it. Okay, gen's not going to start. It's not going to run because somebody pushed the e-stop. But look, manufacturers thought of that and we put a light on the remote annunciator panel and a nice convenient alarm too. Somebody turns the accessory power off to the gen set. It happens. Somebody flipped that breaker down there in a distribution panel. They'll kill the power to the generator set. Battery charger stops, block heater stops. All this is going on. If nobody notices it, that machine is not ready. It is not going to do its job when it's called upon.